Hello, everyone. My name is Vanessa Lieberman, and I am the Department Safety Coordinator for the Food Science and Technology Department. Today, we're going to talk about laboratory safety and explain what all these acronyms on the screen mean. There's a lot of information in this presentation, so please bear with me, and I appreciate your attention and patience. We'll start off with some general lab safety don'ts. Don't eat, drink, chew gum, or apply cosmetics in the lab. These are areas where chemicals or biological hazards are used and could cause accidental contamination. Don't store food in laboratory refrigerators. These fridges can contain chemicals and other hazardous materials that can contaminate your food. Don't leave equipment or reactions running unattended. This could lead to unwanted accidents. Don't work alone in the lab after normal working hours without supervisor's approval. There may come a time when you may need to do some work alone in the lab. However, you must discuss this with your PI. There may be some procedures where working alone poses a hazard and is therefore not allowed. If working alone is approved, make sure you are familiar with emergency procedures and emergency contacts. The notification system within each lab when a person who is working alone arrives and leaves the building is advised. Each lab is responsible for having a working alone SOP. Don't leave your lab a mess. Each lab should be clean, organized, and free of clutter. All chemicals and solutions should be properly labeled and stored. A clean and organized lab helps to prevent accidents. These are the main topics that we will discuss today. The Injury and Illness Prevention Plan, or IIPP, which is filled out and provided to employees and students by the department. The Chemical Hygiene Plan, which is in the Campus Distributed Laboratory Safety Manual. The Lab Hazard Assessment Tool, or LHAT, and Standard Operating Procedures, which are lab-specific and completed and distributed by the PI. Training, such as the UC Safety Training called the UC Fundamentals of Laboratory Safety, and site-specific training, which is done by the PIs or lab managers in each laboratory. The Chemical Inventory System, which uses the online tool called Chemicals, Safety Data Sheets, or SDSs, how to read them, and the Global Harmonized System of Labeling Hazards. Personal Protective Equipment, which is provided by the PI, the Emergency Action Plan, which is provided by and specific to the department, and handling and disposal of hazardous materials in accordance with the laboratory standard or the hazardous communication standard. The Safety Services website contains many resources for all of these topics. The Injury and Illness Prevention Plan, or IIPP, details management commitment and assignment of responsibilities for those maintaining and implementing the plan. It discusses various safety communication systems with employees. The IIPP outlines a system for assuring employee compliance with safe work practices, as well as scheduled inspections and evaluation systems. It also contains procedures for correcting unsafe or unhealthy conditions, safety and health training and instructions, record keeping and documentation, and accident investigation procedures. We will now discuss some of the elements of the IIPP. One of the elements of the IIPP is the Chemical Hygiene Plan. This can be found in the UC Davis Laboratory Safety Manual. The Chemical Hygiene Plan establishes a formal written program for managing the risk posed by health and safety hazards associated with the use of hazardous chemicals in laboratories. It describes the proper use, handling, storage, and disposal practices and procedures to be followed. This plan applies to employees who use chemicals in teaching and research laboratories at the UC Davis campus. It is the responsibility of the employer to provide a workplace free from recognized hazards that may cause death or serious injury. And it is the responsibility of the employee to comply with occupational safety and health standards, rules, regulations, and orders. The Chemical Hygiene Plan also details the rights and responsibilities of each of the following parties as determined by the UC Office of the President and the Board of Regents. Campus administration policies and procedures are the responsibility of the Chancellor, Provost, and Dean's offices. Policy specifics is the responsibility of the Chemical and Laboratory Safety Committee. PI support and enforcement is the responsibility of the department chair. Site-specific rules, training, and laboratory safety procedures are the responsibility of the PI. Personnel are responsible for taking the training, understanding standard operating procedures, reading safety data sheets of chemicals used in the lab, and wearing personal protective equipment. Safety information, training tools, support, and inspections are the responsibility of the campus environmental health and safety team. Again, this plan with all the detailed information can be found in the Laboratory Safety Manual. There are multiple online tools through which training and safety documentation is managed. All of these tools can be found on the ehs.ucop.edu website. This is what the homepage looks like. If you click on the More Apps button, you will see all the options of all the online safety tools. This main page is the workspace page, where you'll find the Lab Hazard Assessment Tool, or LHAT. So let's talk about the LHAT. The LHAT details hazards present in the laboratory and communicates these hazards to employees. This will be different for each lab, as each lab will have potentially different hazards such as chemical, biological, physical, or otherwise. Personnel working in the lab must be given access to their lab's LHAT. Once you have read through it, a notification will be sent to the PI or lab manager letting them know you have completed reviewing the LHAT, and you'll be notified about what personal protective equipment or PPE you will need for working in the laboratory. Because working in the laboratory presents many various hazards, safety training must be completed prior to beginning any work in the lab. Personnel working in laboratories must complete the online UC Laboratory Safety Fundamentals, complete the site-specific training, attend this seminar, and complete any additional training as required by the lab which you will be working in. This additional training will be discussed later on. You must also review the LHAT and watch the video on how to properly use PPE. Obtain the PPE required for your lab and receive training for all laboratory standard operating procedures, including procedures that require prior approval. You must also read and understand the IIPP, the Emergency Action Plan, and the Chemical Hygiene Plan. UC Laboratory Safety Fundamentals is an online course which must be completed by all laboratory personnel before given access to the laboratory. It is an introduction to laboratory safety fundamentals, chemical safety, and general safety. It covers relevant information discussed in the UC Davis Laboratory Safety Manual and rights and responsibilities according to applicable regulations. Site-specific training. This is an example of the site-specific training checklist. You need to receive this training prior to beginning work in the laboratory. In this training, you will learn the location and proper use of safety equipment such as personal protective equipment, fire alarms, safety eye washes, spill and first aid kits, chemical fume hoods, and biological safety cabinets. It will also review proper emergency response and ensure that you have read the department-specific emergency action and injury and illness prevention plans, in addition to laboratory-specific standard operating procedures. Here's an example of a training matrix. These will look different depending on the types of hazards present in the labs you will be working in. Different hazards may require additional training. These are some examples of the different types of online training available. Everyone will need to take the research and laboratory safety training. Certain types of equipment used in labs may require additional training. Ergonomics training may be required if you're working on a computer for long periods of time. If the lab you'll be working in has any biohazardous organisms, you'll need biological safety and medical waste training. I give an additional training on these topics, so if you'll be working in a lab that handles biohazardous substances, please let me know. Animal care training is required for any lab working with animals. So now we'll discuss chemical use a bit more. Prior to buying any new chemicals, check your lab's inventory to make sure you don't already have it. Add each new chemical to the chemical inventory system and place a barcoded tag on the chemical. These are called chem tags. You have to enter the barcode manually into the chemical inventory system when you first enter the chemical. However, after that, you can use a barcoded scanner to scan the chemicals in your lab to log them into your inventory. Read the safety data sheet of the new chemical to determine the hazards. If it requires a standard operating procedure, add it to your lab's existing list or create a new one if necessary. Use proper personal protection. And finally, if you're disposing of the chemical or any waste, it must be disposed of properly and in a labeled and dated container. Safety Net 8 details guidelines of proper waste disposal. All chemicals and solutions, including water, must contain a label with a full chemical name and date and must be stored properly. Chemicals is the online tool for lab's chemical inventory. It can be accessed through the ehs.ucop.edu site referenced earlier. The chemical inventory will show you the name, location, and hazards of the chemicals in the laboratory. We will now discuss chemical safety data sheets, or SDSs. The SDS describes the name of the chemical, the hazardous nature of the chemical, physical characteristics, fire and explosion information, reactivity of the chemical, health hazard information such as health effects and symptoms, personal protective equipment needed when using the chemical, how to handle leaks, spills, and disposal, and any special precautions. Here's an example of an SDS. Each section describes the information discussed on the previous slide. In the SDS, you also find the globally harmonized system of classification and labeling of chemicals, or GHS. This labeling system uses a signal word such as danger or warning and gives a precautionary statement indicating how to properly handle the product in order to minimize risks to the user. Hazards of the chemicals are associated with an H code. H200s are physical hazards, H300s are health hazards, and H400s are environmental hazards. The lower the number within a category, the higher the hazard. So H300 is more hazardous than H304. These hazard codes are also associated with hazard symbols. You will see these symbols on the chemical bottles. Each symbol depicts the hazard associated with the chemical. There are a number of hazardous material control systems to help mitigate the risk of exposure. These are known as engineering controls because they help to remove or contain the hazard if used properly. Examples of these are chemical fume hoods, glove boxes, flammable liquid storage cabinets, biological safety cabinets, and spill cleanup kits. So what is an SOP and why is it important? Standard operating procedures, or SOPs, are known as administrative controls. The purpose of an SOP is to mitigate the risk of exposure of employees to any hazards present in the workplace. SOPs document the laboratory-specific procedures of safe handling, storage, and disposal of hazardous chemicals. PIs and laboratory supervisors are responsible for establishing SOPs relevant to health and safety for laboratory activities involving hazardous chemicals under their direction. CalOSHA requires the use of SOPs for work with hazardous chemicals. SOPs establish a designated work and storage area, determine engineering controls such as fume hoods or flammable cabinets, the proper personal protective equipment for working with certain chemicals, establish procedures for waste removal, and set up decontamination procedures. Here are some examples of the hazard classes of various chemicals that require SOPs. This list is not exhaustive, and the list of all chemical hazard classes that require SOPs, as well as templates, can be found on the Safety Services website. You will need to read your lab-specific SOP prior to using a chemical containing these specific hazards. Now we will discuss personal safety in the laboratory. Proper attire is required in order to work in the laboratory. Long pants or skirts must be worn. In other words, you must be covered from the waist down. Stockings, nylons, and leggings or jeans with holes are not acceptable. You must also wear closed-toed heeled shoes that fully cover your feet. Tying up long hair is also advised. We will now discuss personal protective equipment, or PPE. There are multiple types of PPE to protect you from various hazards. Some examples of these are eye protection, such as safety glasses, goggles, or face shields, gloves, such as nitrile, chemical handling, and higher alert temperature gloves, protective clothing, such as lab coats and chemical aprons, respiratory protection, such as dust and mist respirators, as well as others, such as hearing protection. All PPE must be used properly in order to be effective. I would like to discuss some PPE etiquette. Do not wear soiled or contaminated lab coats in shared or public spaces. This is true for both chemical and biological contamination. Wear clean lab coats for use in autoclave rooms. If you're transporting something to a different location in the building, your items must be stored in clean secondary containers. Do not use gloves in hallways. If you're transporting large amounts of liquids, use a clean cart to transfer your items to avoid dropping and spilling. These items must still be stored in a secondary container. If you're working in another lab, have another lab coat in that lab or bring a clean lab coat with you. This is especially important for those who are working with biohazardous materials. Different labs may have different hazards, and you don't want to contaminate any lab with hazards you're working with in a different lab. Remove gloves before putting on or taking off lab coats. I've seen people touch biohazardous materials or chemicals with gloves. Remember that they need to wear a lab coat, then put that lab coat on wearing those same gloves. Doing this contaminates the inside of your lab coat and therefore any part of you touching the lab coat. Do not touch your face, phone, headphones, or any exposed body part with gloves. Doing so can contaminate your skin or personal items with any of the hazards you have on your gloves. Wash your hands after you move your lab coat. The idea is that your lab coat is contaminated, so once you touch it again, your hands are then contaminated again. Washing your hands after removing your lab coat removes any hazard that was on your lab coat from your hands. Next, we will discuss the Emergency Action Plan, or EAP. The EAP must be in writing and include the following elements: emergency escape procedures and emergency escape route assignments, procedures to account for all employees after an emergency evacuation, preferred means of reporting fires and other emergencies, names or regular job titles of persons or departments who can be contacted for further information or explanation of duties under the plan, a system to notify employees of an emergency, procedures for employees who remain to complete critical operations before they evacuate, rescue and medical duties for those employees who are to perform them, and training for all employees on the EAP. The written plan must be kept in the workplace and be made available for employees to review. You should also be aware of the location of all the exits for your workplace and building, the alarm pull boxes and fire extinguishers, the nearest phone, safety showers and eye washes, first aid kits, and spill kits. These will be covered in your site-specific training. Also, if you will need assistance in the event of an evacuation to safely exit the building, please contact me so we can set up aid and training for these emergency evacuations. Here's an example of the building evacuation plan. These are posted at the entryway to each lab. These detail where the exits are, as well as fire extinguishers and fire alarm pull boxes. This is the emergency evacuation map. This map is also located in the department EAP. It is simple, but details where to meet during an emergency evacuation of the complex. Members of the Food Science and Technology Department will meet on the right-hand side of the parking garage if you are facing the parking garage. In the event of a fire, follow these procedures. If the fire is small, you may attempt to neutralize the threat without endangering yourself. If you are unsure, leave the area, being sure others are out. Close the door. Activate the nearest building fire alarm. Dial 911 from a landline or 530-752-1230 from a cell phone. Stay away from the area and close the door. Go to the agreed meeting place and stand by to advise the emergency personnel when they arrive. So now we'll talk about fire extinguishers. There are 5 different types of fire extinguishers. Class A, which is for ordinary combustibles such as wood, paper, and trash. Class B, which are for flammable or combustible liquids. Class C, which are for electrical fires. Class D for special metals, and Class K for kitchen fires. All buildings in the RMI complex are equipped with combo fire extinguishers that are a combination of A, B, and C. These emit a power that suffocates the fire and need to be checked monthly to ensure effectiveness. So as I just said, these need to be checked monthly. So how do you check the fire extinguishers? Make sure the needle is within the green range. To do this, look at the needle as if you were looking at a meniscus of liquid. Put the date and the initials of the person checking on the tag. And if there are any issues, contact Fire Prevention Services at fireprevention@ucdavis.edu. So how do we use a fire extinguisher? The acronym PASS is a simple, easy way to remember how to use a fire extinguisher. Hold the pin, taking care not to squeeze the handle. Aim at the base of the fire and stand back 5 to 6 feet. Squeeze the handle and move closer as the powder is being discharged. Sweep back and forth to cover the range of the fire. This should only be done when the fire is at the beginning stage. If flames are large, evacuate, and 911 should have already been alerted when the fire started. Keep in mind, a fire extinguisher will only last 20 to 30 seconds. I have linked to a great video on the proper fire extinguisher use. For sake of time, I will not play it now, but I'll post these slides up with links for anyone that is interested. In the event of an earthquake, follow these procedures. Get under a desk, table, or archway during the shaking. Leave the building after the shaking is over. If you're outside during the shaking, stay clear of buildings, trees, or other structures. Dial 911 or 530-752-1230 from a cell phone to report any fires, ruptured pipes, or downed electric lines. Assist injured persons in securing medical attention. Go to the agreed meeting place and stand by to advise emergency personnel when they arrive. In the event of an active shooter, there are 3 immediate actions: run, hide, and fight. If you can't run, hide, and if you can't hide, fight. During this type of emergency, seek help. Call 911 and provide as much information as possible, such as location, what is happening, description of the suspect, and your name and phone number. Silence your phone. However, if you can't speak, turn the phone back on and leave the line open so that police can hear what is happening at the scene. More information can be found on the Safety Services website. I also highly recommend everyone take the online active shooter training offered on the LMS system. In addition to resources for laboratory safety, Safety Services also has resources for personal safety. Some of these resources are the campus emergency notification system called WarmMe. Make sure you're signed up for warming to receive notifications and updates about emergencies happening on campus and in Davis. The Everbridge app is a personal safety app that can be used to quickly make emergency phone calls, set up emergency contacts, or to report suspicious activity. This can also be downloaded from the Safety Services website. Now we will discuss laboratory accidents with a focus on chemical spills. So what causes laboratory accidents? The major contributors to lab accidents are rushing, frustration, fatigue, and complacency. Other contributors to errors or accidents are eyes not on the task, mind not on the task, being caught in the line of fire, and loss of balance, traction, or grip. So let's focus on one of the most common lab accidents, a chemical spill. In the event of a chemical spill, follow these procedures. If 1 pint or more is spilled, or if you're not comfortable cleaning up the spill, call the UC Davis Fire Department or 911 from the landline. Evacuate the room, close the door, and wait for emergency personnel. If the spill is a flammable substance, turn off all ignition sources before securing the room. In case of chemical contact with skin or eyes, flood the affected area immediately with water and seek medical assistance. Remove all contaminated clothing. Do not be concerned with modesty in the event of a chemical spill. Some labs will also keep spare clothing for this purpose. Small spills may be cleaned up by lab personnel using a spill kit. Any acids and bases should be absorbed and neutralized. Flammable liquids may also be absorbed. Do not attempt to block cryogenic liquid spills with unprotected hands. In this case, allow the liquid to evaporate. Solid spills are not usually emergencies. If the spilled material is toxic, use dampened cloths or paper towels to transfer it to a plastic bag to dispose of as hazardous waste. Please also report all spills to EH&S at 530-752-1493. Safety showers and eye washes should be used if someone is contaminated with a hazardous chemical. Remove all contaminated clothing if possible. Rinse in the emergency showers for 15 minutes. If a splash occurred in the eyes, rinse in the eye wash for 15 minutes, holding the eyes open. Call 911 or 530-752-1230 or go immediately to the hospital emergency room. Here's the chemical incident decision chart. Tools such as this can help determine if the spill can be handled by lab personnel or if emergency help is required. Here's an example of a chemical spill kit. Chemical spill kits contain neutralizers for acids and bases, absorbent materials for soaking up spills, brushes and dustpans for picking up used absorbent material, and gloves, aprons, or other PPE. Safety Net 13 contains guidelines for how to clean up a chemical spill. This should be reviewed at least annually. Here are some steps for cleaning up chemical spills. Work from the outside in. Start containing the spill with a barrier of absorbent material to prevent further spread. Remove any physical hazards such as glass with tongs and place in a hard-hold container. Absorb any excess liquid using paper towels or other absorbent material. And double bag in plastic bags or a single hard plastic container and dispose of as hazardous waste. So we talked about laboratory accidents, but what about near misses? These are important as well as they can help prevent an accident from happening in the future. Any incidents or concerns may be reported to safety services. A form for this can be found in the department's IIPP. All faculty members, staff, students, and visitors at UC Davis can participate in making the campus a safe place to work, study, and live by identifying health and/or safety hazards or unsafe conditions by informing those responsible for the problem area. Employees are advised that use of this form or other reports of unsafe conditions or practices are protected by law. It would be illegal for the employer to take any action against an employee in reprisal for exercising rights to participate in communications involving safety. So now let's talk about hazardous waste. Here are some of the hazard classes and their definitions. Toxic substances are any substance which may be harmful to the environment or hazardous to your health if they are inhaled, ingested, or absorbed through the skin. This includes acute toxins, carcinogens, and other chronic toxins with bioaccumulative properties or persistence in the environment. Reactive substances are substances that can produce toxic gases, are explosive, react violently with water, or contain cyanide or sulfide. This includes explosives, oxidizers, reducers, water-sensitive, acid-sensitive, air-sensitive, and unstable chemicals. Flammable substances are substances that have a flash point of less than 140 degrees Fahrenheit and are capable of causing fire through friction, moisture, or reactivity. This also includes oxidizers and flammable compressed gases. Corrosive substances have a pH of less than or equal to 2 or greater than or equal to 12.5 and are corrosive to tissue or metals. Guidelines for disposal of chemical waste can be found in Safety Net 8. Another of the online safety tools is the Waste Program. This tool creates a hazardous waste label and sets a timer on the waste for when it needs to be picked up. All hazardous material and hazardous chemical waste must be picked up by Environmental Health and Safety, or an EH&S approved contractor. Not many chemicals can go down the drain, and drain disposal of non-hazardous chemicals is strictly regulated. More information on this can be found in Safety Net 6. Here are some guidelines for disposal of hazardous waste. Always reduce the volume of hazardous chemicals and minimize the generation of waste. Only order and use what you need. Use the hazardous waste label supplied by the Waste Online tool. For liquid waste, a screw cap leak-proof container must be used. Liquid waste bottles must also be stored in secondary containment. Segregate waste by hazard class. Proper chemical segregation is explained in the Stanford Segregation Guide. Waste must be picked up within 9 months of initial label date, and extremely hazardous chemicals or waste must be picked up within 90 days. Triple rinse empty containers before disposal in the trash. However, some containers that previously contained hazardous materials may need to be picked up by EH&S without rinsing. Dispose of any sharps such as syringes, glass pipettes, and other sharp materials in specially designated rigid sharps containers. This is the online waste tool. Here you can create a waste tag for different types of waste. You can learn how to use this tool by going to Safety Services website and searching waste tracking. This is also accessible by the ehs.ucop.edu site. This is the Stanford Compatible Storage Group Guide for how to properly store chemicals. Please refer to this guide when storing new chemicals or hazardous waste. Incompatible chemicals should not be stored together as they may cause harmful reactions leading to damage and injury. Here are some of the most frequently violated safety rules. Proper management of hazardous waste, proper labeling of hazardous solutions. All solutions, including water, must have a label with the full contents spelled out in English and not chemical formulas. The labels must also have the initials of the researcher responsible for the solution and the date of preparation. Abbreviations may be used. However, if they are used, there must be a list posted in the lab that explains all of the abbreviations. Lab workers must wear protective clothing, the bare minimum being closed-toe and heeled shoes and long pants or long skirt. Lab coat or chemical apron and eye protection must be worn when working with any acids, bases, solvents, powders, or any pressurized or vacuum systems. Lab workers must be trained on all safety equipment and standard operating procedures. And labs must be clean and without clutter, and no food or drink is allowed. This concludes my presentation. Thank you all for listening. I'm happy to answer any questions that you might have. Please feel free to contact me with any questions or concerns that you might have related to safety.